With startups, you're always trying to do is just hone in on product market fit and solve a really important problem for people. We're kind of all product managers now. And there are key moments where you absolutely do need to be in the loop. And you want to be able to express like your intuition and your kind of product judgment. But, basically you don't want to be there doing unnecessary coding.
Just to make that clear, you basically build a Postgres competitor. Is that the first version?
You look at like Open Claude, it's a manager agent pattern. You talk to a manager agent, that agent spawns sub-agents. So suddenly all software is just moving into the space of building multi-agent systems. How do you converge the state? And how do they talk to each other? And how do you have visibility? One thing is like harness engineering, back pressure and bounds, oracles. And like on the other side, it just really brings to the fore the importance of kind of product thinking and product design and service design.
So do you see more software engineers moving into that direction? Is that what you recommend people to look into?
Yeah, for us at Electric.
Hello and welcome everyone to another episode of The Merge, our podcast here right from the CodeRabbit office in San Francisco. I'm super excited because today I'm going to be joined by James Arthur, the co-founder of ElectricSQL. A beautiful day here in San Francisco, a little bit cloudy overhead, but super excited to have you here, James. Could you tell us a little bit more about, maybe for those people who haven't heard about ElectricSQL yet, or about yourself, who's James and what do you do?
Yeah, awesome. Love to. Thanks for having me in. I'm James. I'm one of the co-founders and CEO of Electric. Electric, I think some people may know us as like a sync engine technology. We developed this like Postgres sync engine. We also developed TanStackDB, which is a reactive client store. And so you put those two end to end, and it's a really nice reactive end-to-end application development stack. But more recently, we've been evolving more into data infrastructure for agents. So we're now more of a data platform with a composable set of primitives for building collaborative, multi-user and multi-agent.
That sounds very interesting. All of that, I think, is very timely, and especially in those ages here in AI and in San Francisco. But I think your journey didn't quite start at that part. Yeah, I think you have a very, very interesting career arc that kind of brought you there, starting at, I think, what one could call a digital furniture assembly company like OpenDesk, then getting into pioneering synthetic data at Hazy, and then all the way to ElectricSQL. So maybe you can tell us a bit how that all started and what's the overarching arc that brought you here.
Yeah. Well, I'd love to, and it's a long story, so you should be careful.
All right, we've got time.
Be careful around this one. But yeah, I guess, I've done actually a whole bunch of different stuff over my kind of life and career. Like I grew up in the UK, I kind of moved to London for uni, I sort of stuck around there for sort of 20 years. I then moved to Croatia, and then more recently just moved out here to the Bay Area. But I basically, like when I was about 25, I kind of remembered an interest in computing and just sort of built a computer and taught myself to code. And then I sort of spent a few years coming out of sort of marketing stuff into sort of wanting to do software development. And this was sort of early kind of when the web was exploding. And London, you had this whole thing where it used to be like TV production and video production companies. And then it all sort of went digital. So I sort of did that kind of journey and sort of went from being a sort of wanting to learn how to code to being a professional software developer. And then I sort of wanted to get into like more sort of product and kind of startup stuff. And so I went freelance, and I spent sort of time just sort of trying to kind of spin up projects and make things happen. And then the first one that really stuck was that I was working with this quite cool architecture company called 00, and they were like a proper architecture company. And they'd also started a bunch of the early co-working spaces in London. So it was called like the Hub Network. It's still there today. It was like kind of Hub Westminster and things. And what they did is that when they got these kind of big warehouse spaces, they would put a CNC machine in the space and just make all the furniture for the space, because that was the most kind of cost-effective way of fitting out a kind of co-working space. And so what we did was we took their furniture designs for these co-working spaces, which you could make on CNC furniture, and we turned that into like open source designs that you could download and make anywhere. And so that was OpenDesk. At the same time, we did a project called WikiHouse, which pops up on Hacker News occasionally still, which is like a public domain housing system using the same tech. So that was a sort of period of kind of maker movement, open source furniture stuff. And that was my first kind of journey through like accelerator funding, crowdfunding, VC funding. And there's a long story of kind of where that ended, but I'll pause there to let you.
That's very interesting. I mean, we also tell here on the Merge, the podcast, a lot about the stories of open source. So I think that's actually quite fitting. What was the the reason you chose that open source model at the time?
I think just kind of being into it. I mean, I was like, in a way, when I was learning to program, like the first sort of guy I met who really knew how to program, who I learned a lot of stuff through, was a real open source advocate. Like he was the founder of Freenet and always sort of working on kind of open tech kind of stuff. So in a way, my sort of weird self-taught entry point to software was like open source and distributed systems, both of which sort of come back around kind of in electric. But yeah, just being kind of, there was an era where the internet was this sort of like technology for liberation, right? And, that's certainly where I started. And then it sort of increasingly gets kind of co-opted into more kind of corporate stuff.
That's true. I mean, I feel like you've also, looking at your, your background, it seems like you've always been a little bit on the pioneering side. It might be the liberation of the internet all the way to synthetic data at this company called Hazy, right? Which synthetic data, I think, is everything everybody talks about when it comes to model training. So Hazy was a couple of years before that, though. Can you tell us a bit more about that?
Yeah, I mean, what had happened is I'd sort of done OpenDesk and then sort of stopped, had a couple of kids, moved out of London, and then I basically accidentally became a venture builder for a while, which was like a sort of venture studio thing. So ended up creating a bunch of companies with a good friend of mine, and one of those was Hazy. And we basically sort of started off, like we had another good friend of ours who became CEO, Harry, who really drove the company. And he was really interested in doing a sort of data company. And so we dived in and we sort of saw this stuff around like data agility for regulated industries. And so banks, they've got lots of customer data, but they can't really do stuff with it because it's private and sensitive. And so we were sort of synthetic data came about because what we realized we could do is train generative models to learn the interesting statistical or sort of insightful patterns in the data. And then if we made that model differentially private, it could be like secure from a data privacy point of view to then sort of share and work with that model. And so we sort of basically kind of, invented this idea of creating generative models that could create statistically equivalent data sets that were still safe to work with. You could then later do like data analytics and model training on. And it was kind of, we did a whole bunch of different techniques like Bayesian statistical models. The simplest stuff often turned out to be like the best approach, but we did also get early into generative adversarial networks, autoencoders. And so we were sort of playing around with this whole kind of suite of kind of early generative models, which was in that sort of era more when like things like kind of computer vision were the sort of primary applied AI use cases. This was sort of prior to LLMs. If we'd had LLMs when we were doing Hazy, it would have been a very different journey. But that was fascinating because then it was like, getting into kind of data infrastructure and also like learning. For instance, it was a very enterprise kind of heavy company. We got a lot of kind of coaching in terms of like, how do you do enterprise sales? How do you scale a company that's doing enterprise sales? So that was really, really interesting from that point of view. And then the core tech was interesting, but to be honest, it was also just slightly beyond me because it was real proper data science. And, I'm a self-taught developer. I don't have a statistics background. And so there was I was the CTO, and there was a point to which like I couldn't really steward the product properly because I just didn't really understand the core tech. So I sort of transitioned out of Hazy so that other people who really understood the data science could kind of properly steer the company. And that was around the time I then actually left the UK, had an opportunity to go back to the beginning and start a company, which was what I really was interested in. And that's kind of what Electric is now.
Wow. Yeah. Quite the arc. I think interestingly enough, this still Hazy was hugely successful, right? I mean, there was I think I read about a Microsoft prize that was given and a TEDx prize. What time did you found the company? Was that?
Which year?
Which year?
You'd have to check LinkedIn. I think it's about maybe 8 or 9 years ago now. I think so. We could just I can't.
Yeah. So definitely pre-generative AI era.
Yeah. AI. It was sort of there were vertical AI stuff happening at the time, but it was much sort of simpler applications. And we just got lucky, I think, because like we were sort of looking around for funding, and we sort of managed to get kind of some initial funding into it as a company. There was some like cybersecurity accelerator stuff we did. But then we applied for this Innovate AI Microsoft thing. And I think basically Microsoft at the time were partly differentiating from other big tech companies with a focus on data privacy. So our sort of theme of data privacy was quite aligned,
Yeah.
and we got this $1 million prize for like being the best startup in Europe, which also came with like half of it was investment from Notion Capital, and Notion were really, really helpful at giving us a bunch of really good coaching. There were some really good people involved, like Stephen Millard, Keith Washington, etc., who really, in terms of sort of, teaching us how to do that type of enterprise.
Yeah, wow, super impressive. I think there's a couple pinpoints that will come back here and here later, which one of them I think is what you said is the simplistic things are always working very well. I think I saw that at least looking into some of the things that you did coming back. And then the other part is the data privacy part, right? So that seems to be a very important point to you as well, thinking about your local first kind of approach to things. So can you explain to me how did that span over from Hazy to ElectricSQL, and what's the combination of the story there?
Yeah, I mean, there's definitely some sort of themes there where I guess it kind of comes all the way back to what you were saying about like early roots in open source tech and OpenDesk. It's like, I think a lot of developers just sort of share this same sort of ethical view on like how things should ideally be. And like, yeah, you look at like, there's a whole sort of model where with SaaS systems, data became the product. You have sort of user exploitation as a business model. It's not really how it was meant to be. And so, for instance, the local first software movement, which was very influential for Electric, it was like Martin Kleppmann, Adam Wiggins, Peter Van Hardenberg, I think there's one other author, from like the Ink and Switch lab, but like they established this manifesto for like an ideal way of making software, which combined a bunch of stuff on the sort of user experience side around like kind of instant, reactive, real time, with these principles around data ownership. And certainly, yeah, for me, that was really attractive when you sort of see that space, is that there's this sort of ethical footing for how you could build software. And so we've been involved in like creating Local First Conf. We just did a Local First documentary film now. And I think Local First is established as a really, really interesting movement where it's actually really coming even more into force in the mainstream now, because a lot of stuff that's happening with AI, for instance, is like you're starting to see software differently with sort of software factories, and software is more like clay that can be malleable. And like the Ink and Switch kind of manifesto across like Local First and malleable kind of barefoot developer stuff is all actually what is now playing out right at the front of market with how like the best teams are kind of viewing their software. So just as a sort of movement for the future of software, it's a really interesting movement. Yeah.
Right.
To give a shout out, we organize Local First Conf every year. Next one's in Berlin in July. There's a Local First Software Community, which Jons here in San Francisco organizes. They do meetups. That's lo-fi.so. So, there's a whole bunch of Local First community stuff, which if you're interested in, dive into through.
Yeah, we can definitely link that here. I think there's two parts to one of them, of course, is like the entire ethos behind the Local First community, and there's also some technological benefits, right? Maybe you can explain a little bit about the principle local versus, the entire fetch and response.
Yeah. I think if they're sort of slightly aligned in that there's this thing where like if you're using an app, it's like, who owns your data? And it's like, well, if you do, well, if the data's in the cloud and you need to go over the network to the data, then you kind of can't use your app unless the cloud service is online. And so that's what sort of led, I think, with the Local First ideas into like, well, actually the data should be on the local device, which is kind of what Local First means. But then actually, if you look at that more as a like a software architecture for application development, then actually systems that are architected like that are just better because everything's just instant. You don't have the network on the interaction path. Like reads are instant, writes are instant. And then you move state transfer out of the imperative space where you're sort of writing code to go across the network, and you move it more into a declarative sync engine architecture. And if you look at the evolution of how you've done sort of state transfer, moving the data between the back end and the front end in application development, actually this is kind of the optimum pattern. It's kind of where GraphQL was going to, but kind of local first sync engine architecture just is the best way of building applications. And so, yeah, there's almost two sort of poles in that community, which are there's people interested in it just because it's how you can build like modern, instant feeling, reactive real-time apps. And you have this software like Figma, Linear, etc., which are great exemplars of the quality of product that you can build if you build on that architecture. And then there are people sort of driven by the more sort of ethical data ownership sides, and the community kind of between sort of local first and sync tech, embraces both sides, and actually both sides are kind of fused together in a way.
Yeah, it works great, right? And I feel like that's also what you set up first when you started ElectricSQL, right? And then maybe you can walk us through exactly what you were trying to achieve, especially with the first beta and then before the pivot.
Yeah.
Yeah,
absolutely. Just my personal journey with Electric was, I kind of had an opportunity to go, right, let's kind of, start another company, which is really what I want to do. And so I was just looking at kind of what I was interested in. And at the time, I was just seeing a lot of interesting stuff around like geo-distributed data and sort of data at the edge. Like Cloudflare was kind of like taking off, and like Cloudflare storage was getting built. And so I just personally sort of just dove into that area a bit, where you kind of just go and find out kind of what's there. And my first idea was making like a geo-distributed Postgres, a sort of active Postgres as a service, where you could just have like local replicas that were really fast, and then you could have a global network of those. And I actually built that as a kind of prototype SaaS service. But I then went and talked to a bunch of people about it, and I was surprised that there were like people who wanted to invest in it, but then also like developers were just asking me all the sensible questions about like consistency guarantees and the sort of complexities. And so just personally, that led me to go down the rabbit hole of sort of discovering all of the cool literature around CRDTs, and eventually consistent database systems.
What are CRDTs? Explain that.
Yeah, so CRDTs are conflict-free replicatable data types. So they're kind of a primitive for being able to develop systems where you can't have conflicts. So if you have, there's this whole thing where like if you have sort of distributed data, you can distribute on the read path with like read replicas, and then have a single writer, and that's kind of sensible, and you don't have sort of problems. Whereas if the moment that you distribute writes out to different nodes, you just suddenly introduce all of these challenges where you can have a network partition, they can't coordinate. And so it's the classic CAP theorem stuff where you have to choose two out of consistency, availability, or network, where you always have network partitions. So choose consistency or availability. And so you have this whole class of distributed database systems which would be available, so keep working in the event of a network partition.
Right.
And suddenly you've got like two writes to the same data at the same time, where you can't know which one came first. How do you resolve the conflicts? And so conflict-free data types, which were invented by Mark Shapiro, Nugo Preguiza, and Carlos Bequeras, three leading distributed database researchers based in Europe, basically solved this by having a particular design of a data type where you preserve all of the history and then always deterministically materialize the value. And so if you then build these systems on CRDTs as this key building block, then you can have like database systems that kind of can have these magic properties of being like instant and locally available, but never having conflicts, and always eventually resolving with consistency. So I basically, it's absolutely fascinating stuff, and it's all sort of tied into the local first software movement, because a lot of that core technology then sort of made these patterns possible. And so with Electric, actually, I got in touch with those academics, and they were keen to collaborate. And so I actually started the company with two of the co-inventors of CRDTs, and then they introduced me to my original co-founder, Volta, who had worked with them as a database researcher over many years. And he invented a whole bunch of core technology in this space, like rich CRDTs, the bounded counter CRDT. He built the first relational, eventually consistent databases, etc. So he's a real kind of like proper distributed database geek, and I'm much more of a generalist. And actually it was then together that what we decided to do first was create a next generation geo-distributed database system based on CRDTs and the sort of strongest modes of eventual consistency.
And that was the precursor to Electric.
Yeah, that was kind of first. That was then, that was that kind of era, and we sort of basically did it, and we built a team, and we sort of developed out this geo-distributed database where the kind of value propositions were things like low latency and geo-distribution, and did a lot of customer discovery and customer validation style stuff. And eventually we just sort of qualified it out because we were, it takes 10 years to build a database and 10 years to mature it. And as relatively immature tech, it was very hard to serve the scale of customers who needed that type of system. But what we discovered was that there were just a lot of people who were trying to build software on this sort of sync engine local first architecture, and exactly the same sort of hardcore database replication tech was the key thing technically that you needed to be able to power these type of local first or sync engine apps. So we sort of basically took all the same sort of research thinking and just sort of applied it to going, well, hang on, let's build the sync engine layer for local first apps. And that was a sort of key thing where like maybe the first time that people might have heard of Electric through Hacker News or something, that's what we were building. And then, I mean, it's been a couple of still kind of major evolutions from them to kind of continue the story. So, I think with startups, what you're always trying to do is just hone in on product market fit and, solve a really important problem for people. And what we tried to do first, because we came out of that research heritage, was we tried to build a bit too much of a complex, magic, perfect local first software stack. And we sort of did our best to build that out, but it was a really big surface. And it was very difficult to build a system that was like reliable and then actually delivered on the proposition.
Yeah, just to make that clear, you basically built a Postgres competitor. Is that the first version?
Yeah, exactly. It was actually, I mean, the very first version was like sort of an Elixir-based interface to a kind of Erlang-based geodistributed database. Yeah, so it was very sort of niche.
Yeah.
And it was trying to conform the CRDT space, which was all sort of like Erlang tuple types, to a more standard relational kind of data interface. And that's why it was sort of SQL, right? Kind of electric sort of SQL as the sort of model on top of kind of CRDTs. But I think, but also what we tried to do was hold on to things like guarantees, like finality of local rights, and we were managing the right path migrations, and it was very much a sort of integrated platform to make it work. Very, very hard to make this sort of magic data platform that was like kind of Meteor or Firebase, but for SQL and magically kind of instant.
Yeah.
And so that's where we had to really simplify. And so that's when, one of my other co-founders then really importantly joined. So Kyle Matthews, he was one of the co-founders of Gatsby. And so he'd been through a journey of building out a much more kind of mainstream dev tools platform with like much larger use. And he'd also been involved in like the design of a lot of their data delivery infrastructure, where they were like working with Fastly, because it was a sort of hybrid system between like a React platform and a static site generator. But actually what it did was an awful lot of content delivery. And so when he came in, he'd been sort of digging into local first after selling Gatsby to Netlify. And he just brought a whole bunch of product insight into how to simplify down so we could build on like a simpler, more reliable system that kind of did less, but that was actually useful.
Right.
And we also then reinvented the sync engine to be based on this CDN-based data delivery protocol, which was inspired by his work at Gatsby. And actually, now that we've also evolved more recently into this durable streams stack, which is more data primitives for AI apps, that is based on the same insights in data delivery protocol. So we basically built this Postgres replication system or Postgres sync engine based upon a kind of CDN-based data delivery protocol. We then generalize that data delivery protocol to basically work for any database, any data type, any data stream. So everything from like Postgres sync to any database sync, you can give it a standard schema and it'll just generate magic database sync, but it also does things like YJS, real-time presence, AI token stream. And so that all runs on that same sort of heritage of basically going, actually, let's simplify this down to just do this very clever CDN-based data delivery that gives us like ultra low cost, ultra low latency, infinite scale, like kind of egress out of the CDN.
Yeah, sounds like an amazing promise, and success speaks for you. So let's shift gears a little bit towards the era of AI, because I think there's a lot of interesting thoughts that you also have on that. I think you wrote a very provoking piece, which was called "Bringing Agents Back Down to Earth," which kind of, that's why I pinpointed earlier, making things more simple, right? What is your approach there? Because I think the idea is very interesting. You're saying that people are overcomplicating the entire agent architecture, and how does that fit into Electric's paradigm?
Yeah, I mean, look, there's obviously lots of great kind of infra out there where people are building exactly the right stuff, but also AI has been a very hypey kind of space, right? There's a lot of buzzwords around sort of special parts of the stack, and that sort of bringing agents down to earth piece it's a bit like a sort of turning the database inside out piece, where like what we do with Electric is we provide these data primitives. And so we have this new core data primitive called durable streams. And a durable stream is basically a persistent, addressable binary stream. And then one of the things we've done is we built this layer on top of that called durable state, which, as I mentioned, is basically you give it a standard schema and you just get like a database sync kind of for that schema based on that. And if you take that type of primitive, like durable state, then you can basically do things like workflows, agentic systems, durable execution, just using standard web tech. And so the kind of the theme of that kind of bringing agents down to earth piece was kind of like, look, there's an awful lot of sort of snake oil around the agentic system. But if you just have like a database or like a durable state primitive, then actually it's just web systems. You can use your existing frameworks, your existing tooling, and you can build the control flow. You can build agentic loops. Like it's kind of, it's simple stuff.
So you don't need all the vector databases and much of the very fancy memory stuff that people build around the agents.
Yeah, well, you kind of, you need it when you need it, right? And some apps may need kind of vector stuff, and some apps may need like a kind of proper complex operational memory system. But you can go a long way in actually just starting stuff off by going, okay, boil this all down. It's basically a database.
Right. And that's just to touch back onto the durable streams. I think you also open source that, right? And explain real quick. I think in simple terms, it's basically tackling the problem that you have sometimes when, let's say, you are on a train, you're going into a tunnel, you send your message off, and then the stream breaks off to OpenAI, and then suddenly all your tokens are kind of wasted. Is that?
Yeah, I mean, exactly. That's kind of the inspiration for it. So, I mean, like people listening, if you're kind of building AI apps and you're using, say, these kind of AI SDKs like the Vercel AI SDK, like there's the Tanstack AI SDK now, like you have these kind of used chat hooks, and then there's normally like a server-side events protocol for kind of streaming. Like you kind of send a message to your API, you send it on to like OpenAI or Anthropic, it comes back and you sort of stream the response into the app, and that's where you get that sort of token writing out experience. And so just one of that, what that's done is it's really kind of highlighted the challenges with this sort of state transfer layer, which we've always been addressing with this type of sync tech, where because you have these longer running responses, you are just really vulnerable to like the network falling over or walking around a corner or going into a tunnel or whatever scenario it is, or someone restarting a server. And so, yeah, a lot of, I think with AI apps, because a lot of apps were just like getting very fast to kind of first utility. It was like, let's just find a way to actually kind of wire this up on the happy path and ship it. But then, how many times have you used Claude and like the session breaks and you have to restart it?
It happened to me earlier today,
And so, durable streams was like, what we've seen is where we sort of started in application development, which was more like structured interfaces. People have been increasingly using the Electric stack to build AI apps. And then it's like, it was quite obvious that what we needed to do was provide a primitive that you could do this kind of AI token streaming over. And basically where we were working on Postgres sync, like it doesn't always make sense to route your tokens through a database like Postgres because it's like centralized and you have latency. But like actually you're sensitive to kind of latency on those responses. And so that's why we needed like a different primitive. And as I say, that's where we took the same delivery protocol for the Electric Postgres sync and generalized it into this new durable streams primitive that then becomes this real Swiss Army knife primitive that you can kind of layer other protocols on top of. And that's basically a lot of our focus in sort of rounding out where we still have the ability to do this kind of structured data sync, which is still important for building application interfaces. But you then sort of add in these kind of durable streams-based kind of AI native primitives. And that's like a suite of services that you can use with your choice of web framework to build these kind of reactive streaming kind of AI native apps. And importantly, it's all based on this sort of heritage of like multi-user collaboration, which of course is increasingly kind of multi-agent.
Multi-agent swarms using durable states.
Yeah, exactly right. And I think, it's such an interesting time to be sort of building this kind of dev tooling because I think we're all just living through this same crazy evolution in software. And so, maybe back when writing that article, the idea of sort of multi-agent swarms was like an idea or an argument that we were sort of making. Hey, we can see that coming up. But like, if you think about the last couple of months, software factories, kind of gas town, you're like suddenly sort of seeing people building these systems for like orchestrating swarms of agents. Like even the kind of like core kind of agentic coding tools are increasingly spawning sub-agents to preserve pristine context. You look at like OpenClaw, right, which has gone
Yeah.
totally kind of pop. It's a manager agent pattern. You talk to a manager agent, that agent spawns sub-agents. So suddenly all software is just moving into this space of building multi-agent systems. And you suddenly move into this world of like distributed systems where you've got like loads of agents and they're all doing stuff in parallel. And like, how do you converge the state and how do they talk to each other and how do you have visibility into that? And so for us, it's like we've been building this kind of sync tech, but suddenly it's just kind of going, well, the key main use case for this stuff is clearly being able to provide data primitives so that developers can build multi-agent systems.
Right. I mean, yeah, data transfer seems to be the key point for this new agent economy, right?
Yeah.
Another interesting point that I wanted to touch upon, because you said it before, I think another cool thing that you guys built was this Lite PG vector thing that lives also in the web. Can you explain us what that is?
Yeah. So one of our projects is PG Lite, which is a Wasm build Postgres. So it's like a lightweight Wasm Postgres. So it's one of the things, for instance, like where we do Postgres sync, you can sync data into a PG Lite instance, which can be running in like a node server service or in the browser. And it's like a much more lightweight embeddable database. And it also so we've extended it with these like sync plugins and kind of live queries. So you can do like reactive programming on top of it in the browser. And also it supports extensions. So you mentioned like PG Vector. So with PG Lite, you can like compile PG Vector to Wasm, embed that along with the database build, and you actually get like a first-class vector database inside the client. And so it's not our primary solution for application development. Like TanStackDB, much more lightweight, much faster. It's based on this differential data flow model. It has very nice primitives for optimistic mutations. So if you're doing sort of more like sort of standard front end work, that's generally what we recommend. But PG Lite, if you're building an agentic system where you need a vector database, or if you're building maybe like a desktop or mobile app where it's kind of okay to have the overhead in the bundle size, it's really cool. And also a lot of people are now using it in things like CI and test and dev. So it's now the default database for Prisma. It's built into like Google Firebase tools. Like there's a whole bunch of systems where basically instead of having to provision out an extra database to run, say, tests, you can just basically have a database inside your process. You don't have to do any of the same sort of heavy cleanup. You don't have sort of external systems. It just radically simplifies what you need in like dev, CI, and test for running like a proper Postgres. And I think people used to do that a lot with SQLite in like dev and sort of Postgres and prod.
All the time. But the agents do it now.
Yeah. But it is good. But that's one of these things where you then get this sort of dissonance between like, I've got a production bug because it actually turned out that the database worked different. Whereas PG Lite, it's like the same pattern, but it's just Postgres. So there's no kind of weird dissonance between the data types or some sort of, transactional consistency model or something.
Yeah, you just touched on something interesting as well, and I think earlier this month you published another interesting article that I found, which talks about configurancy and like keeping systems intelligible when agents write all the code, right? Which is, I mean, you're in CodeRabbit, we're all about that, right? So, can you talk a bit about that? What does that mean?
Yeah, I think we all, right, are just going through this period where sort of you're moving from software development as a sort of craft into kind of engineering the harness for kind of more sort of software factories. And so, for us at Electric, like, everyone on the team is kind of working with coding agents to get stuff done. And so suddenly there's a sort of blizzard of PRs. And actually you sort of, it really puts a spotlight on the bottleneck of kind of product planning, design, kind of working out what's important, where to kind of put your energy into kind of steering to get the right stuff. And so that kind of concept of configurancy is kind of in a way like how things come together and what the actual like impact of the changes is. And so like what we've worked on, and Kyle on the team has been kind of leading this in terms of steering the product work, is like we explicitly include a configurancy delta in our product requirements documents. And it's literally like a YAML structure. And like the agents can read it, but also we can use that to like literally track our definition of the product. And a lot of what we now spend our time on as a team is actually getting together to sort of codify what impact we want. And, obviously, this is a sort of transition period and it's not a complete magic software factory yet. There's a lot of actual sort of manual work and still sort of building the tooling. But, we can all see, I think, where things are going, which is that, you're just expressing actually the changes you want in the world, and then the agentic system will be able to make it so. And I think that sort of concept of configurancy is actually a really, really important one in terms of sort of how we evolve our understanding of what we actually do as software developers. One thing is like harness engineering, back pressure, evals, oracles. And like on the other side, it just really brings to the fore the importance of kind of product thinking and product design and service design.
So do you see more software engineers moving into that direction? Is that what you recommend people to look into?
I don't think you have a choice, right? I mean, it's kind of, this is done and dusted. I mean, I don't know. I don't know whether I have a skewed perspective because, as it happens, I've been doing software a long time and I can sort of understand what's happening under the hood. So I guess I don't have the experience of people working with coding agents who don't have that kind of. But yeah, I think basically, software development, what the humans do just obviously sort of moves upstream more into product. And, you have this framing of like working out how to design yourself out of the loop, which was always what, if you think about sort of management as a sort of discipline, that's always been like what you would do as a manager. We're kind of all product managers now. And there are key moments where you absolutely do need to be in the loop. And you want to be able to express like your intuition and your kind of product judgment. But, basically, you don't want to be there doing unnecessary coding. So, this is the sort of task I think that we're all just doing across nearly all software teams, is like transitioning from reading the code to sort of building the harness so that we don't have to read the code, but still making sure that we have the right sort of input and the right control point in the process. Because you can't just sort of devolve that sort of what you actually want to make so to agents.
Very interesting point, because this Saturday I was just at the first birthday of Claude Code, and they did a big hackathon.
It's amazing, right? It's only a year old.
Yeah.
Yeah.
It's absolutely crazy. And also, if you compare some of the projects, I went back in time and I looked at some of the vibe coding projects that I did, like a AI assisted coding, AI engineering project I did a year ago, and how different they were in terms of output and how rapidly it all changes. And they did a hackathon where people from all around the world could participate, and then they flew in the winners. And the first prize was actually a lawyer, non-technical, just building software. He was very funny, his presentation. He said he had no idea about what was going on in the code base, but he built a very impactful project. And it kind of was very thought-provoking, because it really made you think as a software engineer, right? We all have that sort of pride that at least there's one domain that we know very well and where we can point out the mistakes. But then, of course, with the speed of projects that you're building now, you're realizing that once you've switched into a completely different programming language that you haven't touched before, it's completely new to you as well. Where do you think we bring the most value moving forward in that economy?
I think we just need to sort of see this stuff as tools, right? I mean, the tools evolve, and the tools are evolving exponentially because technology compounds. So, we're getting better tools. These agents are like, they start off as like better autocomplete and used to have stuff built into IDEs and, assistive coding tools. And they've now sort of rapidly accelerated to, the level, if you're prompting them well and providing them good context, just the level of work that you can get out of things like the latest codex, the latest opus is insanely good. And then, those tools are being put to work building better tools. And I think, it's not, there's no one thing, because it's just a moving, it's a moving kind of puck. And I think the thing to do as a software developer, or just anybody, because what we're living through in software is going to rapidly come to the rest of the economy, is you just have to be able to sort of ride that change and sort of, try to kind of stay kind of on top of and sort of orchestrating that exponential growth in the technology. So it's kind of a 21st century skills thing, right? It's kind of learning how to learn, and it's being able to sort of stay adaptable and, realize that the kind of puck is moving, and also to some degree just resign yourself to kind of, diving in, right? It's totally new. Nobody has the answers. It's a pathless land, and that's incredibly empowering. And if you're kind of, whether you're sort of getting into this now or whether you're sort of reinventing yourself at my age, it's just as exciting, because it's such a privilege to be able to sort of go through this shift with the sheer pace of change, the stuff that's happening at the moment.
Beautifully said, yeah. What do you think about the entire, we talked about Claude Code and like how amazingly it changed the way we program. What do you think about the open source model world, especially for coding? Is there any favorites that you currently see? Any models that you use?
Yeah, I don't use any kind of open models. I mean, I think it is going to be really, really interesting when you sort of start to be able to get kind of the similar capabilities on local models. And I think coming back to sort of local first patterns,
Exactly. Yeah.
You'll have models in your kind of phone that can work with your data, and it's your data. And I think that can sort of change some of the economics of applications and software. But I think in what we've seen in reality is that like any domains which haven't been able to just actually track the bleeding edge of these more centralized services are just radically behind for now.
Okay.
So, if it's some sort of corporate domain where they're not able to use Anthropic because of kind of data privacy concerns or something, it's just like, they're just not anywhere near kind of what's actually happening. And so I don't really, for me right now, it would be wonderful if this stuff were open source, but it's just not really what's actually going on. What's actually going on is that it's just incredible to be like, we've been given these absolutely magic tools. Like the capabilities of the LLMs are incredible. And so I think what's interesting in like open source and software space is that in the agentic layer, which is kind of where you bring software development to bear to harness the capabilities of the LLMs, like everything is obviously happening in open source because the infrastructure, the best tools have to be open source. And so I think that's the kind of layer where it comes in, whereas kind of, more like things like sort of open weights is just not stuff I'm sort of on my radar in a way.
Interesting, because I think for your trajectory that you're on, the complete local app would need a local model, right? So I think it would be, at least I find it super interesting to explore. The other day I was on a flight for Christmas to Germany back, and I was coding the entire flight on QN. I think it was 9 billion parameter.
How was it? Yeah, how did it feel?
I used Z, and it was quite nice. It actually brought me back to being more involved, because right now you have you send outpost 4.6 on a long running task, and then you come back and the results are amazing, and you tweak a couple things there, and you go more into that product manager role. But in this Q&A, that was December, so probably right now there's already newer, better models out there. But it was great because I felt much more deeper involved in the code base again, which for like a smaller project, of course, that's kind of nice. I don't think it's the future yet, but I was very impressed because it's been a while since I used the coding open source model, and the results were really, really good. So I think there is a place, and I think maybe for data privacy, but also for other applications where you got to have something running on a phone or maybe somewhere in a remote place, it could be interesting. And then, of course, ElectricSQL and local sync would be of utmost importance to have a self-sustaining application, I think.
Yeah, you kind of need sync with that. So if you have that sort of local data enclave, then you just need to sort of sync to get the data in and out. And yeah, totally. I mean, I do think that kind of thing is likely to be quite strategic for the big, like say, particularly mobile operating systems. So, even if you have a local model, whether that is really something that like you install yourself, it's a tough sell because you'd be having like a massive model taking a massive amount of memory. And like if you're an operating system developer and you want to actually control a high quality user experience, and also that a whole bunch of sort of like, data privacy and security concerns around it, it feels much more likely you would get the continuity of being able to say work with a model on your phone with like airplane mode, but still potentially just actually sort of more like controlled by Google or Apple. Because I think they'll just be able to deliver a better quality user experience. And for the vast majority of people, that's what will matter. I mean, maybe for kind of developers for that coding use case, that's where you're going to get more of a sort of open source kind of thinker who would want to be sort of in charge of the whole stack. And I think, already on desktop, right? I mean, you can have however much gigabytes of RAM on your desktop, and you can run really good models. Yeah.
I mean, look at the entire OpenClaw wave, right? People buying tons of Macs and setting that up.
It was nice software development though, whilst it lasted. Yeah, just the enjoyability of actually like going back to the code. Coding itself was such an enjoyable discipline that it is a real shame that it kind of doesn't exist. Because I love nothing more than actually kind of going, don't have any distractions, get in and work out how this software needs to be structured.
Exactly.
That has slightly been taken away from us all. Yeah.
No, yeah. Actually, I have to say I found myself in parts of more involved in the code, and then parts more conscious about the prompts that I was using. So because now you find yourself slacking sometimes in the way that you prompt these models because they're so good. So you You just jumble something in if you want something quick fix. At least I find myself doing that every now and then if it's just something smaller. But when I was on that plane, I was really carefully engineering every prompt and the context, and in order to get the results that I needed to. Otherwise, it wouldn't work.
Yeah, old school.
Yeah, exactly. That sense. Well, I think this kind of brings me to the end of my docket, at least. But I have a couple other small rapid fire questions that I wanted to ask you. So yeah, feel free to answer in one sentence or elaborate if you feel like longer. But yeah, we're gonna start with one question that I ask everybody who comes on the show. What's your favorite programming language?
Elixir.
I was thinking so. I took that note. Why?
It's just, I mean, my sort of journey as a programmer was like kind of ASP, Python, sort of Java, lots of JavaScripty stuff, did a bit of Ruby. So I came a bit from sort of dynamic language spaces, but often languages like Python and Ruby that struggled with concurrency. And so just sort of moving into the OTP model with these beautiful concurrency primitives, but a sort of Ruby quality DX, and then a really high quality ecosystem stewarded really well. It's just such a pleasure to code in. And there's something about Elixir where you're so much more confident. Like, even though it's not a statically typed language, although they are progressively adding proper type support to the language, but it's always felt very sort of stable to refactor because it's functional. And so, yeah, it was also the sort of first language where I properly sort of, moved to being a functional programmer. And I think there was something kind of just like about the simplicity of that, like explicit data structures, functional programming, combined with the syntax, combined with the concurrency model, combined with the developer tooling. I mean, it's just, and what we're seeing now as well with agents is it is a bit of a resurgence where the Elixir ecosystem moved very quickly to do things like add usage rules into the modules. Like, there's always been really good documentation, but that's like documentation is literally installed with the dependencies, and so the coding agents can find it, and there was standardized tooling. But the OTP architecture, which is what Elixir is based on, which is the sort of Erlang Beam VM, is basically an actors system with like actors and supervisors and message passing. And it is just obviously like the perfect stack for agentic engineering. So whilst Elixir has been a kind of relatively niche language compared to something like TypeScript or Python, it's almost like when the agents can choose their own language. We had an Elixir meetup when Jose Valim, the creator of Elixir, was here in San Francisco a few months ago, and I was doing a little talk for it, and I did a bit of prep for it where I asked Claude, okay, forget everything in your kind of near-term training set that you've been told to say. If you actually evaluated which programming language you would use for your own purposes, which would it be? And it chose Elixir.
I bet that made a very good intro talk.
Yeah, that worked the room.
Yeah, nice. Okay, next question. Favorite AI model?
I'm kind of long-time Claude, basically.
Yeah.
Just particularly, I think, because of the productization around Claude Code, but then you sort of become quite familiar with it. So I would drop between Claude and Codex, but I'm kind of Claude pill.
Yeah. So yeah, Claude and then Claude Code as well as the coding agent and the harness, I guess.
Yep.
Okay. All right. I guess that answers the next one as well. Terminal over IDE.
I think, I was never an IDE user.
Yeah.
I was always like, kind of text editor and terminal for a long time. So
Vim?
exactly. For me, no, never Vim, never Emacs. Always just like very kind of basic, like TextMate and Sublime Text.
Okay.
Kind of no tooling, no real automation.
Yeah.
Type with two fingers. But I just always liked being in like a text editor and a terminal, and it's like my stack. And so, sort of cursor windsurf was never my thing. So Claude Code was just like,
thank you.
Perfect.
I've been waiting for this. Okay. Sync or fetch, if you could delete one pattern for every code base on Earth tomorrow, which one dies?
Well, clearly fetch.
All right.
Why would you fetch when you can sync?
No, exactly. That's right. Most overhyped concept in the AI agent space right now?
It's a good one. I'm trying to think of like an actual kind of real answer. I'm not sure on that one. Sorry.
That's all right.
We'll
We'll bring you on again at some point. Then you think about it.
I'll remember it in like 5 seconds. Really good answer.
All right. Last question. One piece of advice for a developer who wants to stay relevant as agents write more and more of the code, right?
Yeah, I guess maybe kind of one thing is like digging into kind of product design and service design stuff. Like I remember earlier in my career when again sort of trying to sort of move more into like products and startup stuff. I remember diving into kind of service design as a discipline.
Yeah.
And it's fascinating, right? And you get a lot of this sort of, it's sort of similar to sort of lean startup kind of methodology stuff. It kind of overlaps a bit, But just sort of, so diving into kind of that kind of thing is I think as you sort of move more into kind of product manager and stewardship, just sort of understanding more of these sort of principles about how you actually design kind of holistic services and how you do user research and what the kind of, there are real sort of disciplines in that stuff, which often just feels a bit like uncodified common sense. But, actually there's a whole load of really good kind of models and patterns that you can kind of internalize and then execute from everything from sort of go-to-market strategy, service design, product strategy, organizational design.
Yeah, it seems like we're all becoming more responsible for how the user and the end uses our product. Was before that we could blame that on the product manager or the ticket was not well written or.
There's these sort of nice ideas around sort of inversion of control. And so you often get organizations that are based on, say, sort of command and control. And it's sort of, it's like old-fashioned enterprises. Doesn't really work. A lot of tech companies have sort of busted through that. But a lot of the sort of systems thinking in service design is about how you move intelligence to the edge. And that is exactly what you're doing with back pressure and harness engineering.
Well, thank you so much, James. It's been a wonderful conversation with you. Thank you for coming on the show. To everybody here who's listening, check out ElectricSQL, check out the work they're doing, and check out the durable streams, the durable states, build an agentic system locally. And tune in the next time. Thank you for listening.